Okay, so I'm going to do a video on 2.3 and 2.4, so these will be together. And so we're continuing our talk about dealing with different types of equations. We talked about circles, talked about linear equations, talked about ellipses, and now we're just going to go to the general functions and function notation. Function notation is just your, well, y equals, say x, that's just your basic linear, right? When we talk about function notation, we're just changing y to f of x equals x. F of x just means I'm plugging in something in for x to find out the answer. So f of 2 means I'm plugging in 2 in for x, and I'm finding out the answer, right? So this would be 2. Right, say if it was y equals x squared, then it'd be f of x equals x squared. That'd mean 2 squared, so that'd be 4. So that means I plugged in 2 for my x, and I got an answer of 4 out. So notice I get a point out, right? X and a y. I plugged in an x, and I got a y. Function notation, it just means f of x. So f of x, not f times x, it's f of x, meaning I'm taking whatever's inside the parentheses, and I'm plugging it in for that variable x. Okay, so my domain, when we talk about domain, that's my choice for x's. So my choices of x's, or my x values of the function. Okay, and we kind of already did this a little bit before with writing interval notation. In our last test, every problem that had inequalities or anything like that, you were supposed to write your answers in interval notation. And interval notation was just basically your answers for x, right? So in a similar way, your domain is not your answers for x, it's your choices for x. Because when I'm in function notation, I am not solving for x, I'm solving for y, but I get to pick x's, right? And so you get to pick any number of x's from negative infinity, oh, terrible infinity signs there, and to positive infinity. Ooh, that's maybe even worse. But it's my choices for x's. And sometimes I have a limited choice for x's. So here's a polynomial with a degree of 3, right, an x cubed in it. Every polynomial, any polynomial, your choices for x's or your domain will be from negative infinity to infinity, right? And again, we want to write these in interval notation. Okay, so when we're just looking at basically, just the number line, just like kind of like we did for the answers for those inequalities. Well, here we're talking about domain, and it's our choices for x's. So what it means is I can plug any number in for these x's, and I will get an answer out, right? If there's some number that I can plug in that I won't get an answer out, that I'll get like undefined or no solution or something like that, then I can't choose that x, so it would not be in my domain. The specific ones are like square roots, so the square root of x. X can be everything except for less than 0. So it can be everything but less than 0. So it would be from 0 to infinity. That would be my domain of this function, f of x equals square root of x. So my domain would be from 0, including 0, because I do have an answer for square root of 0, it's 0. But I don't have negative 1. Square root of negative 1, there is no real answer for that, so that negative 1 is not in my domain, and every other negative would not be in my domain. I can't choose those x's and plug them in and get an answer out, like get a y out. And our domain always goes from left to right, from negative infinity to positive infinity. Okay, so if my answers are, say, my choices for x could be all numbers, so then I would write negative infinity to infinity. Could be just like the last one, from 0 to infinity. It could be from negative infinity up until 0, and maybe it can't be 0, right? So domain is your choices for x's. What can I plug in for x that I get an answer out? Okay, so you have to choose an x value, but you get an answer out. Okay, so domain is your x values there. Your range is your y values. Okay, what answers do you get out? What are the answers that you get out? Oops, answers you get out. Okay, so what are the answers? So if I can plug in any number, what are the answers that I can do? So you had the problem y equals x. I can plug in any number and I will get an answer out, right? So my range here, because it's linear, right? So that's a line. So domain is your x's, which is the horizontal line, right? So your choices for x's, what can you plug in? What numbers can you plug in here? Where y is your answers. What answers do I get out? And as I can see, I continually go down this way and continually go up. So that means my answers for this function, f of x equals x, would be negative infinity to infinity. And these answers start from the bottom. I write from the bottom. So when I talk about negative infinity, that means I'm talking about way down here. Okay? From the bottom to the top. And so when I talk about top, I'm talking about way up here, way up that way. Okay, so your range is your y values. They're the answers to this. And so you can kind of tell if you're looking at a graph, if my graph goes upwards, then I'm going towards positive infinity, so my range would continue to go up. If I'm going down, my range is going negative, right? If I stop, if I don't have an arrow, that means I'm probably stopping somewhere, right? So if I erase that and say I have a point there and it starts here and goes up, that means my range would start at -2 and go up into infinity because it continues to go up. So that's your domain, your x's, and your range, your y values. Then we talk about a relation. So a relation is an ordered pair. Ordered pair, x, y, and so it's a relationship. What is the relationship between x and y? So a relationship between x and y is an equation, y equals x squared. That could be the relationship. How is x and y connected? Right? How do they relate to one another? Well, they relate to one another whenever I square my x, I get my y. Right? So that's the relationship between them. So it could also be a relation between x and y. It could be y squared equals x. So the relationship is whenever I square my y, I get my x. So that's the relation. It's an ordered pair between two variables that explains how you get from one to the other. Now a function is for every x value that I have. So for every x value, I have one y value. So for every x, there's only one y value. That is a function. Okay. So a lot of my equations, okay, or equations, or sometimes what we call functions, are just relations. When we talk about a function, an actual function, if it is a function or not. So every equation that has a y and an x in it is a relation. It's not necessarily a function, even though we call them functions. To be a true function, the x value, for every x value, there has to be one y value. So for instance, a y equals x. So for every x I put in, I only get one y out, right? So I put in 1, I get 1. I put in 2, I get 2. I put in -1, I get -1. So for every x value, I get one y value. It's a 1-to-1, not quite 1-to-1, but for every x, there's one y. So I have one arrow coming from my x and going to my y. So another one could be like this. Say -1, 0, 1, 3, 5. I'm making these up. And 7. So if I have -1 goes to 3, 0 goes to 5, and 1 goes to 5. So here, for every x, I go to 1y. Even though I have 0 and 1 going to 5, I still just have one 1x to 1y. Okay, so this would be a function. This would be a function. Okay, because I have 1x going to 1y. Even though they're going to the same y here, I still only have 1x0 going to 5 and 1x1 going to 5. Now this one, I'm going to make not a function. Again, I'm just kind of making these up. Okay, so here, 3 to negative 4, 5 to negative 7, 5 also goes to negative 7, and then 7 goes to negative 7. So here, this is not a function because right here, right, it's okay that 5 went to negative 7 and 7 went to negative 7. That's fine. That's just like this one right here. But because there's two arrows coming out of 5, and they're going to two different places, that means it's not a function because this x doesn't go to 1y, it goes to 2y, so it is not a function. Okay, so if you're given an equation, you can easily just start picking x's, right? You can make a table, pick x's, and see what you get as your answer. Plug them in and see what you get, and you can make a table, and then you can see, does every x go to every y? You could also graph it, right? So if I made a table, I could start graphing, especially if it's linear, then I only need 2, right? 1, 1, 2, 2. Now I can draw my line. Look at my line, right? There's a thing called a vertical line test. Vertical line test. So wherever my graph is, I'm just going to draw vertical lines. And does my graph in black here cross that vertical line more than once? Okay, if it crosses more than once, then it's not a function. This only crosses here, crosses here, crosses here, crosses here, and so on. So this is a function because it only crosses once. All right, if it crosses more than once, then it is not a function. For instance, say if I have this graph, I draw my vertical line. Look, it crosses twice. 1, 2. So this one would be not a function. Okay, so it looks something like this, where 5 went to negative 5 and negative 7. The next one is if you have a set notation, right? So a list of ordered pairs, right? Because we have a relation. That's ordered pairs, right? So 1, 3, negative 2, 5. 7, 9, and 1, 7. Okay, so on this, when I'm given a set of ordered pairs, right? Ordered pairs means I have two, they're in order, and I have two of them, right? So here I just want to go look at my x's. 1 goes to 3, right? So that's okay. Negative 2, it's a different x, so it can go to 3 if it wants to, but it goes to 5. 7 goes to 9, that's fine, right? Because I don't have any x's repeating, and 1 goes to 7. Oh, I have the same exact 1, and it goes to two different places. It goes to 3, and it goes to 7. So this is not a function, because I have 1x going to two different y's, so not a function. Okay, so look for no repeating x values. If they do repeat, then they have to go to the same y. Okay, so if they repeat, so I could have this point be 1, 3, and then say again I had 1, 3, that'd be fine because it's going from 1x to the same y, so that'd be fine. So look for no repeating x values. If it doesn't have any repeating x values, then you're fine. It is a function. But if you have repeating x values, you got to see, do they go to the same y or different y's? And then also you could always do the vertical line test. Okay, so that's two ways that you can do it. Okay, now we're going to look at increasing and decreasing of functions. We're looking at our graph, and where does our graph start to rise, go up, and where does our graph start to go down? And we always look at these graphs of increasing and decreasing as, we always look at them as from left to right. So I'm looking from left to right, okay? That's how I'm looking at it, and I'm saying, where's my function going up? Where is it going down? Right? And then it's going up again here, right? So I'm looking at where does it go up? where does it go down, and then constant means where does it stay the same. So if I had a graph something like this, see that, right here in this section it would be constant because it's staying the same. I have the same exact y value. It's staying the same. My y values are not increasing, right? Increasing means I'm where my y's getting bigger at, or not where my y's getting, well, yeah, on my x line where my y's getting bigger. Basically, that's what it's saying. So we always read from left to right, and we're always marking down just the x values. Okay, so we're just even though we're looking at y values, we're only writing down our x values. So here it'd be, okay, so from -5 until this point, say -2. So we'd be increasing from -5, and it hits -5, to -2. That's where we're increasing. Okay, so notice I wrote down my x values, not my y values. All right, I only wrote down my x values. That's where it's increasing at. Right, I'm not saying where does it start increasing, like what value is my lowest y here and what is my highest y here. I'm asking where on my x's is it increasing, where on my x's is it decreasing, and where on my x's is it staying the same. Okay, so when we talk about increasing, like I said, we read from left to right. And as we read from left to right, where on my x values does the graph start going up, and when does it stop going up? On my x values, right here. On my x values, where does it start on my x values going up, and where does it stop going up on my x values? So you are looking at the y's because your y's are telling you where it's increasing, right? If my y is lower and my next y is higher, that means it's increasing, right? But you're not writing your y's down, you're writing your x's down. Where on your x axis does it start increasing, and where does it stop increasing? Decreasing would be the same thing. We look at our x-axis, and where does our graph start going down? So where on the x does it x-axis does the graph start going down, and where does it stop going down? That's decreasing. Okay, so on my x-axis from left to right, if my graph is going downwards, where does it start going downwards, and where does it stop going downwards on my x-axis? So say 2. So then this one would be from -2, right? And since I included this up here, then I probably want to include that -2 down here. And then we would include 2, +2 here. Okay? Constant means where is my graph a horizontal line? Where is my graph a horizontal line? On my x-axis, where's my graph a horizontal line? So on the x-axis, where is a horizontal line? Okay, it has to be a horizontal line. It has to be a line. Okay, it's never a point. So even if my graph comes up to a certain point and goes down, this right here, this point right here is not constant, right? It's not constant. To be constant means it has to have multiple x's in a row that have the same y value. Okay, so it has to be a horizontal line. Constant is not a point, it's going to be a horizontal line. So where does the horizontal line start? So where does it start on x-axis? On x-axis. And where does it stop on x-axis? Okay, and then and these will also be in interval notation. Okay, these answers will be in interval notation. Okay, so here would be the technical definitions, right? As 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 I read from left to right, so as my x's get bigger, that's what this is saying. As my x2 is bigger than my x1, as my x's get bigger, as I read from left to right, my y values, right? So this is just saying I'm getting my y value. When I plug in this x into the equation, into the function, I get a y answer. This is just y. This would be y1. That means that my y's are also getting bigger. That's what that's saying. So as I read from left to right, my y's are getting bigger. Okay, decreasing would be as I read from left to right, my y's are getting smaller, right? My previous y is bigger than my next y. That's what this says. Finally, constant, as I read from left to right, as my x's get bigger, my y values stay the exact same. Right, so there's the technical definitions. Okay, so here's an example for you. So if you want to pause the video, you can do this. You can identify what is your increasing range, right? Where on your x's, or increasing domain, say better for it, right? Since we're looking at our x's. Where is your decreasing domain, and is there any constant domain? Okay, so you can pause the video, you can try this. Okay, so increasing, where's my graph increasing? Well, it's starting to go up here. Right there it's going up, and right here it's going up. Okay, so here it starts at, I'm looking at my x values, right? So -2, and where does it stop going up? Right here at 1, and then it restarts at 3 and goes up until 3, 4, 5, 6, until 6, right? So remember, I don't care about my y values. I'm just looking at my graph. Where does it go up? Where does it go down? I'm just looking at my x's. So increasing, I start at -2. It does include it, right? There's no open circles anywhere. So they're all straight. It's continuous. Okay, there's no open circles or no holes or anything like that. So -2 to 1. Okay, but then it restarts at 3 and goes to 6. Right? So since it restarts, we're going to have to join these together with a union. Is it decreasing anywhere? Is it going down anywhere on my graph? I don't see it going down anywhere, but I do notice that I kind of have a horizontal line here, right? That's a constant. So from 1 to 3, it's constant. From 1 to 3, it's constant. And since I did brackets around 1 and 3, that means I'm going to do parentheses, because that 1 is already included here and that 3 is already included here, so I want to do just a normal parenthesis here. But it's not decreasing, so you could say the empty set is fine, or you can just leave it blank. Okay? Okay, now let's look at this. Here's another function. So this is our function f of x. And we want to look, where is it increasing, decreasing, or constant? So as we go from left to right here, we're looking at where is it increasing, decreasing, and let me add an arrow here. Okay, so that arrow means it's continually going up here and going to the left, right? So that means if I'm reading from left to right, that means it's going down. Oops. It's going down here. So from -infinity, from way over here, -infinity, it's going down until this point right here, which is 1. So it's decreasing from -infinity until 1. And it does hit 1. Okay. Then our graph starts to go up at this point, and then it stops going up at this point. So which is at 2, right? Because I'm looking at my x's. On my x's, it is increasing. Right, so if you want to do, here's a way that I'm thinking that you could do it. Right, so -infinity, so you draw it this way and then stop right here. Right, it stops going up, so that would be my domain for when it's decreasing. Then it's increasing from this point up until this one, so that is from 1 to 2. So from 1 to 2, and since I did a bracket here on the decreasing, I'm going to do a parenthesis here and then do a bracket here. And now it's staying the same. I have a horizontal line from here to here. Okay, so horizontal would be constant. So that's from 2, and I already have a bracket around 2, so you can do a parenthesis until 1, 2, or 2, 3, 4, 5, until 5. Put a bracket around that. And now, as I look again, it is going down, right? So we're going down here. So from this point all the way, and it continues, right? So this arrow is pointing down and to the right. So that means it's continually going to the right, and it's continually going down. So it's continually decreasing from this point, which is 5, to positive infinity, because we're going to the right. So positive infinity. And since there's two groupings here, and since I already used 5, I can do a parenthesis there. I need to put a union there. Okay, now we're talking about linear functions, right? Linear functions is just like I said at the beginning, right? The most basic linear function would be y equals x. For whatever x is, y is the same thing. That's what that means. Or if we do function notation, it would be f of x equals x. So that's a linear equation. The most famous one that you probably remember is y equals mx plus b. Y equals mx plus b. All right, that is slope intercept form, because we're given our slope, which is m, and our intercept, which is b. Intercept form. Probably spelled that wrong. That's okay. Okay. And so if we write in function notation, it's just f of x equals mx plus b. Excuse me. Sorry. Okay. So that's slope intercept form. Then we have another one, which is point slope form. So if you think about it, what you were given for slope intercept form, we were given a slope and an intercept. An intercept is the point, right? An intercept is it's a y-intercept. So it's a y-intercept, so that's 0, comma b. So that's how you would graph that point, right? So the intercept is a point. It's called the y-intercept, and it's 0, always 0 for your x and b. So I could literally plug in 0 for x. So I could plug in 0 right here and multiply by m, which I get 0, and then add my b. So whatever that b term is, I could graph at 0b. Okay, the other form is point slope form. So what do you think we're given there? If slope intercept, we're given a slope and an intercept. What do you think we're given on point slope? So that would be a point. Here's your y value, y1 of your point. M, here's your slope, and then m is times by the quantity x minus x1. And that x1 and y1, this is your point. So your point is x1, y1. Right, so there's your point. And your slope is just your m. So that means that this y and this x literally stay y and x. Until you enter a number in for x, this y and this x stay the same. So if you're asked to write the equation for, if you were given a point and a slope and you're asked to write the equation for point slope form, you literally leave this y and x in there. And then you just plug in your slope and then plug in your x value of your point and your y value of your point. But remember, it's minus that y value. So minus means opposite, right? So negative y means opposite of what your y was. So whatever, if my y was, say my point was 2, 3, then I would enter in y minus 3, because I'm minusing my y value, which is 3, or taking the opposite of this value, which is 3. Opposite would be negative 3. My slope, so I'd have to be given a slope, so say n is 5. So 5, and then my x stays x here, and then minus my x value, so minus 2. And then if we were just giving 2 points, if we're given 2 points, we could literally plug in 1 point right here, and then the other point right here for this y and this x, and that would help us solve for m, right? Our slope. So slope is equal to, you might remember this, your y2 minus y1, the difference of your y's over the difference of your x's, right? Because slope is rise over run. You rise with your y's and you run with your x's, or you rise with your y's and you run from your x's. That's how I remember it, and I'm just silly like that. But so rise over run, or it could be your change in y over your change in x. That's what that means with the triangles. Alright, and the last form is standard form, and that's ax plus by equals c, where a, b, and c are just numbers, kind of like our quadratic form, right, or our quadratics, we have ax squared plus bx plus c equals 0, or a, b, and c are just numbers. So same here, a, b, and c are numbers, right? So they don't include the x's or the y's, they're just numbers, they're coefficients, right? Coefficients a and b and the constant c. And here what we want to do is we usually use this to find intercepts. So like x-intercept and y-intercept, right? X-intercept is some x value and 0 for your y, and your y-intercept is 0 y value, right? So literally I could just plug in 0 for x into my equation, and then solve for y. So then y, this might be my y-intercept, y would equal your c over b. And then to write that point, it would just be 0, 0, comma, your c over b. And so that would be my y-intercept. Now the x-intercept, you do the same thing, except for you would plug in 0 for y and solve for x. So that's why this form makes it great. Like slope, intercept, and point, slope form are always kind of, at least slope intercept is set equal to y. So if you plug in 0 for y, it's a little bit harder to solve for x. But here it's nice to solve for x because all you have to do is plug in 0 for y, so that eliminates your b, and then you just have to divide by your a. So x would equal your c over your a. And that's all x would equal. So then here's your point, would be c over a, comma 0. That would be your x-intercept. So once you have two points, you can draw a line, and that's what a linear is, a line. So all we need is 2 points to draw those lines. Speaking of lines, we have horizontal lines. Oops. We have horizontal lines, and horizontal lines are always y equals. So that might not make sense, but they're just y equals some number. So you think a horizontal line, that should be x equals, right? But y equals some number, like y equals 5, means that all my values of x will give me a y value 1, 2, 3, 4, 5 of 5. No matter what my x is, my y will be 5. So notice how that makes a horizontal line. Okay, so that happens when your slope is 0. So whenever your slope is 0, you will have a horizontal line. Okay, a vertical line will happen when x equals some number. Okay, so if x equals 3 means no matter what y I'm given, positive y or negative y, my x will be 3. So 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. So I have a vertical line. And that one is when your slope is undefined. Because undefined, right, I could walk, if I was standing here, I could walk across this line just fine. If I was standing on a vertical line, I could not walk on it, I would just fall, right? So it's undefined. Okay, now let's look at graphing. So graphing slope-intercept. Here, basically, you can make a chart if you wanted to. These are the simpler ones, right? So if you had some equation like this, and we're asked to graph that. So if you want to, you can pause the video and go ahead and graph this and see if you get it. Okay, so when graphing, all we want to do is just find 2 points, right? So we could find the intercepts, but all we need is just 2 points. So if you want to, one way is to make a table. Pick a couple x's, click 0, plug it in right here. 0, what's 0 times -2? 0, 0 plus 6 is 6, right? That's my y-intercept, right? Right there, your b. You just graph that point. And then I can pick 1. 1 times -2, that's -2. -2 plus 6 is 4. So I picked 1, and I got 4. So then I would go 0, 6, 1, 2, 3, 4, 5, 6, put my point, and then go 1, 1, 2, 3, 4. I have 2 points, now I can draw my line. So that's one way to do it. Another way is to find your intercepts. Like I said before, right? Plug in 0 for x, find out what your y is. And then once you have your y-intercept, you can find your x-intercept by plugging in 0 for y, which is f of x. So 0 equals negative 2x plus 6, and I could solve this one. So subtract 6, divide by 2, so x equals negative 3. So that means you plugged in 0 for y, and you got negative 3 as an answer. So negative 3 is an answer, right? Yeah. Negative 3 as an answer. Oh, wait. This was negative here. So that needs to be negative. That needs to be negative. So that didn't make sense because I was going to go graph. Negative 3 would be over here, which doesn't make sense to my line I already graphed. So I had to go back and look. I had a negative 2x. So that means that needs to be negative. Negative and negative divided by negative is a positive. So it's actually positive 3, which I can see right there. So 0, comma, actually this one's 0, comma 6, and this one is 3, comma 0. So I could graph it by my intercepts, or I could graph my 1 point first, and then I could use my slope, rise over run. So from the first point I graphed, right here, 0, 6, I could use my slope, which is a negative 2. So negative 2 over 1. So I could rise negative 2. That means I go down 2, 1, 2. These are not points when I go down. And then I run 1. So that would give me that point, and then I can draw my line. Okay? Okay, how about this one? What if I were given 2 points, can you write the equation? A linear equation, right? So first of all, you'd want to find slope. So you'd want to find slope, which is your y2 minus your y1 over x2 minus x2, or minus x1, sorry. And then, so it doesn't matter which one you start with, you just want to start with the same point, right? So I could start with this point, and I could go 2, or sorry, my x's are on bottom, 2 and negative 1. Then I would have to go minus 4 and then subtract 3. Or I could start with this point. I just have to make sure that whatever I start with, I have to start with that same x on bottom. Right, so I start with the y on top and the y on bottom from the same point. So that one would be subtract minus 1, and this one would be subtract 2. So we can see we get 5 over 1, and this one we get a negative 5 over a negative 1, which is the same thing as 5. So my slope is 5. So once I have that slope, then I can go to point slope form because I'm given 2 points actually, and now we have a slope. So it doesn't matter which point I choose. I can choose any of them. So y minus y1, y1 I'll let be negative 1, equals my slope 5. Now I just have to choose when I do my x, I have to choose that same from that same point. X minus my x value, x1, which is 2. And then I simplify, so y plus 1 equals 5x minus 2. So that's in point slope form. If I wanted to get slope intercept form, then I would just distribute this. I would get y plus 1 is equal to 5x minus 10. And then here, if I wanted to, I could get to the I could get to slope intercept by subtracting 1. So y would equal 5x. Slope intercept form, you just solve for y minus 11. So those would be the same equations, and then I could actually just move over my x's and my y's on one side. So if I subtracted 5x, so minus 5x plus y equals negative 11. The only thing when you put it in standard form, your x's always need to be positive, and you can't have any fractions on them. Okay, so no fractions on your x's and no negatives, right? So if we multiply everything by negative, then we get rid of that negative. Okay, so then we would have it in, that would be standard form. Alright, so when we talk about average rate of change, that's just talking about slope. So when I ask you to find the average rate of change, that's just asking for your slope. Okay, and your slope is your y2 minus your y1, right? So that'd be your f of B minus f of A over B minus A, right? Because the f of something means the y value, right? So right here I have f of B. So what that means is that's my y value when I plug B in for x. So that means B is my x. So notice how my B is right there, which is my x. Because remember, I take on the denominator. It's your x2 minus x1. Well, here's your x1. Here's your x2. And then here's your y2 and your y2 and your y1. So that's in just a different form, right? So that's if you're just given any graph. Here's your x1. Here's your x2. Here's some point. Your y value, right? Here's the y value height, right? So this point would be A, comma, f of A. That'd be the point. And then here, your height for this one would be f of B. Right, so this one's f of A. So then the point for this one would be B, comma, f of B. And so that's how I got this slope formula here. Okay, so in economics, revenue, we're talking about revenue. That's R of X equals X, the number of items, times P of X, which that's the profit of each item. Okay, so to find the revenue, right, how much I make, well, I take the profit of each item, P of X, and I times that by the number of items I have, and that creates the revenue, right? To create, so this is a little p. Okay, this one for profit, to find how much profit, this is a big P. Big P, big P. Okay, that is the total profit is taking my revenue minus the cost. So revenue minus the cost. Minus the cost. Now we'll get my profit. This is the profit of each item, right? So this is how much, well, really that's how much the price of each item is going to cost, right? The price of each item, we'll just go with that. Let's just say price of each item times how many items I have. That's going to create my revenue, right? How much I'm making, and then to figure out how much profit I make, I got to take the revenue minus the cost. Okay, so there you go. So you can find section 2.3 is on page 199, and section 2.4 is on 211. So this is 2 lessons together. That's why it was so long. So you'll be able to use this. Also, if you look at the finish notes, I put a problem on those notes that's already been worked out, and it's one of your problems that is similar to your homework problems, probably on page 211, I think. I can't recall which number it kind of looks like, but it's dealing with the price and the profit and the revenue and the cost and everything. So you could look through that example to help you out.